Hello, everybody, and welcome. Advent of Code is still happening. It is day 9, and I'm very excited to be back. Today, like on any of the previous days, it is a Monday. We had another puzzle, as usual. Had a great time solving it today. But I want to hear from you. If you're out there, say hello. And if you managed to solve it, let me know. Let me know how your feelings were about today's puzzle. I'd always be curious. I have to admit, me personally, starting to get like slightly more nervous in the mornings, slightly more fidgety maybe, as the days progress. Because you never know what kind of twists are getting thrown your way. I just grabbed from my shelf a little book called Mazes for Programmers. Because I'm getting a little worried that maybe, one of these days, we might need like an A star or something like that. Some strange little pathfinding algorithm. So I decided I'm just gonna put that one under my pillow and hopefully just absorb the knowledge through the osmosis. Not sure if it's gonna work, but at least, if push comes to shove, it'll be close enough to my nightstand that I'll be able to reasonably look something up. Let's take a look here. I couldn't defrag part 2 before work today. Okay. Yeah. These are puzzles that also just like they take a while to sit down. And especially if you take maybe a shortcut on the first part, you might pay for that in the second bit. Depending on how you approach things, you might just, have to start pretty much from scratch. Was a lot of pain and suffering for me. I'm curious, Johnny, was that mainly because you had to debug a lot or something like that? Oh yeah, and by the way, if chat is not working for you, make sure you reload that page. Because it is enabled and people are writing things. And I want to hear from you. I got the job done, not really optimal though. But here's the real question. Do you like the way your code looks, Rob? Because if it's idiomatic, then, in the plurality of dimensions that you can optimize for, you have optimized potentially code readability, who knows? Or maybe it has very few tokens. Today was hard. Yeah. Oh, here's a little bit of praise for yesterday's stream where we had Vitaly on, who did show us a little bit of Rust and Rust Rover, which is quite exciting. Which, by the way, if you're excited about Rust Rover is currently available, or is generally available as free for non-commercial use. So perfect time. Had to finish after breakfast. Yup. These are just real time constraints. Oh, look at this! Other folks also have this book. That's amazing. Jonathan bought the Mazes for Programmers book, and the puzzle today was a bit of a hassle. Glad that I had a string representation to debug. Sometimes this stuff pays off way earlier than you might think. In issues where we're working with like 2D arrays or 2D lists, it's like the second thing I write. I'll be honest with you, I don't even wait until I hit a problem. I'm just like we're writing a little debug view because it'll make iterating so much easier. Part 2 was the first thing this year that really bit me, and I couldn't solve in one sitting. Okay, interesting. And the examples really needed to include greater than 1-digit numbers. Okay, Yeah, there's a little trickiness. We already got some little hints and bits sprinkling in here, which will all make a lot more sense once we really dive into the problem statement as well. So that's going to be quite fun. Oh yeah, here's Johnny's answer. I coded a flawed part 2 by accident, solved part 1, then went back to part 2, but it wouldn't give the correct answer even though the example worked just fine. Those are always the toughest ones, where you have the example input and then you try to generalize it and it doesn't work, and now you got to stare at an output that's 100 times longer than what can reasonably fit in like my working memory, which is always tough. I had a really weird bug that I fixed with a drop 1 on the final disk image, which is really hacky. Hey, again, like we had on previous days, sometimes it's all about covering up your coding crimes, right? Oh yeah, Zelt says, threw my initial convoluted solution away, solved it in a nicer way, and now it's also correct. Sweet. Yep, there's a lot of folks being tripped up by those 1-digit indices, which is tricky. So I can't wait to dissect this more and see what kind of approaches we have here. Int array for the win. Now that one, Maya, that one is quite interesting because if you, dear viewers, haven't checked it out yet, on day 2, we had Michael Zarachinsky, who's the lead language designer of Kotlin, on this show. And we talked a little bit about arrays and a famous tweet from Roman Yelizarov, which mentions that arrays in Kotlin are maybe one of the more shameful areas that we have. So interesting to use int array, but hey, those are those primitives you might wanna work with. But yeah, we're gonna dive into all of that in just a second, and of course, I'm looking forward to bringing on a guest for that as well. But of course, in case this happens to be the first stream that you catch, first of all, welcome. Now is the best time, what does the saying go like? The best time to start Advent of Code in Kotlin was on 1st of December. The second best time is right now. So, of course, welcome. And I want to make sure that you are also aware about all the cool things that are happening with Advent of Code, because we're running an entire campaign around this. And we're also very proud sponsors of Advent of Code. Besides all of these live streams that you've already managed to tune into either on YouTube or on Twitch, we also have leaderboards, and you can join one of those, and you can either compete for the top spots, or you can also just be in the leaderboard just to see what other people are doing and solve a couple of things yourself at your own time. Regardless, you have the chance of winning some exclusive Kotlin swag. The blog post that I just linked in the chat is also the place where you can find resources like our GitHub templates that are based on Gradle, on Amper. It gives us some links to previous solutions, some tips and tricks, and so on. And of course, the other big part that we've been checking in on over these last couple of days is the GitHub topic, the AOC 2024 in Kotlin topic. Once again, I very much encourage you to tag your repositories with this topic. Why? Because it also gives you the chance to potentially win some AOC in Kotlin swag that you can't get any other way. And checking in on this, I think the last number we saw here was 833. So it's very nice to see, even at this kind of later stage, get another 20 repositories matching this. This is once again your call to also do this. And of course, this is also our call for you to try something new with Advent of Code. Whether that means trying a kind of different style of programming in Kotlin, whether it means trying stuff out like Kotlin notebooks to iterating, and like we did with Roman Belov just a couple days ago, or building some visualizations with, for example, a wonderful framework like Compose Multiplatform. So with that, I'm also very excited to segue over to introducing my guest for today's episode, because it is none other than Victor Kropp, the team lead for Compose Multiplatform at JetBrains. Hey, Victor, nice to have you here.
Hello, Seb. Hello, viewers. Thanks for having me. I'm excited to be here.
Yeah.
Yeah.
How's it going with Advent of Code so far this year? Are you participating actively?
Yeah, I'm trying to solve all puzzles, but as all the years before, at some time it happens, like you have some family matters, and you get sick, and so usually drop around the second week or third week. I hope I will go through all the puzzles this year. I say it every year to myself. Well, yeah, and I'm really excited that today's puzzle is quite suitable to our topic.
Yeah, it's gonna be exciting. A little elf, I think, told me that there might be some Compose Multiplatform visualizations coming later in the stream. So make sure you stick around to take a look at those. And of course, if you're not familiar with Compose Multiplatform yet, I'm also just going to drop a quick link to the landing page into the chat here. And of course, besides the tagline of developing stunning shared UIs for Android, iOS, desktop, and web, all with Kotlin and with established APIs, we will hopefully also see some of this in action. So I'd say for this, it's just time for us to dive straight into the dramatic reading portion, so that the visualization part can come sooner. So let me just throw on my hat here. We're keeping the tradition. I just got bonked in the nose by the little bauble here. And once again, before we dive into day 9, just want to shout out here that we in the Kotlin team at JetBrains are also very excited to be sponsors of Advent of Code, and we are very excited to be supporting something that allows people to engage with their programming skills and to really bump them up. So yeah, let's take a look at day 9. Disk Fragmenter. Another push of the button leaves you in the familiar hallways of summer-friendly amphipods. Good thing you each somehow got your own personal mini-submarine. The historians jet away in search of the chief, mostly by driving directly into walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input, he's already generated. For example, 2 3 3 3 1 3 3 1 2 1 4 1 4 1 3 1 4 0 2. The disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 1 2 3 4 5 would represent a 1-block file, 2 blocks of free space, a 3-block file, 4 blocks of free space, and then a 5-block file. A disk map like 90909 would represent 3 9-block files in a row with no free space between them. Each file on disk also has an ID number based on the order of the files as they appear before they are rearranged, starting with ID 0. So the disk map 12345 has 3 files. A 1-block file with ID 0, a 3-block file with ID 1, and a 5-block file with ID 2. Using 1 character for each block where digits are the file ID and dot is free space, the disk map 12345 represents these individual blocks. So we got a 0, then we got 2 free spaces, then we got 1, 1, 1, we got 4 free spaces, and then we got 2, 2, 2, 2, 2. So 5 2s. The first example above, 2, 3, 3, 3, 1, and so on, represents these individual blocks. First, we have 2 of the 0, then we have 3 spaces, then we have 3 of the 1s, then we have 3 of the spaces, we have 1 of the 2s, and so on. The Amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 12345, the process looks like this. We start in our original configuration, we take a block from the very end, and we move it to the leftmost free space block over here. We continue doing that with the second one, the third one, the fourth one, and the fifth one. The first example, which was a whole lot longer, requires a few more steps. But once again, we see the pattern. The latest 9 gets into the first spot, then the second 9 in the second open spot, the 8 into the 8, and so on until no spaces remain. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it instead. Continuing the first example, the first few blocks' position multiplied by its file ID number are 0 times 0 equals 0, 1 times 0 equals 0, 2 times 9 equals 18, and 3 times 9 equals 27. 4 times 8 equals 32, and so on. In this example, the checksum is the sum of these. 1,928. Compact the Amphipod's hard drive using the process he requested. What is the resulting file system checksum? And we can also take a brief look at our puzzle input here for a second, which is one very, very long number. Okay, Victor, what went through your head when you read this, presumably this morning?
Yeah, I was lying in my bed still when I first read this puzzle, and I thought, yeah, great, we get a great schedule for this live stream, because it is the greatest task to be visualized. And also, I remembered good old days, so if I don't remember MS-DOS or Windows 95, where we did such disk defragmentation quite regularly.
Yeah.
And for a reason. Yeah.
Yeah, I mean, it's also like the visualization. Let me just pull up like a quick like block diagram. Maybe something like this, or the older style, like Windows 95-ish, defrag, Windows 98. That's definitely something that is wonderfully mesmerizing. I'm just realizing that apparently there's a simulator for this as well that can just do that. And that also makes noise, so I'm going to mute that. I apologize if that came through on the stream. So, hey, look at that. That's very cute. Okay, so maybe we might be ending up building something similar here, huh?
Yes.
Great. So what I'm just going to do is I'm going to take my screen off the page here, and we will just bring your screen up and make that visual. And here we go. Did you actually? I'm very sorry. I know there's an entire thing to discuss here. Did you really put the entire day 9 input just in a single string?
Yep, I did.
That's a long line. That is a long line.
Yeah. Not sure how long is it. We can check. I just copy pasted it, and it's 20,000 characters.
Of course, yeah. I'm sure the Linta's gonna be real happy about that one.
I don't care about them when I'm solving these puzzles because, yeah, the main thing is to get the right answer here, and
So let's see how we get to
everything
that.
else just doesn't matter.
Yeah.
But also today I was thinking about visualization from the very beginning, and this may affected my solution. So don't judge me for some decisions. I'm not sure how good they are. If I wouldn't need any visualization, but for my task, for my goal, for example, here we see the whole disk structure as the mutable state list of. I'm not entirely sure that this is the best data structure to hold this information, especially with this type conversion. But we'll get back to it in a second. So yeah, as Seppo already announced, I have a sample string here and the input. I usually put the task input into a separate file, but today I decided not to do that, and I will again explain it a little bit later. And then as soon as I realized that there are a lot of integers there and file IDs starting with 0, I needed to have some constant for free space on my disk, and it would be min value, integer min value. Just to be sure that it will not accidentally be misjudged as a file. So the first task with every puzzle is to parse the input, and here I choose to use a sequence, which is my favorite use of suspend functions in Kotlin, which is not coroutines. So you can build a sequence with suspend functions, and it will be evaluated. Each element will be requested from it when needed. Actually, after I wrote it and realized that I anyway need to convert everything to list, I may have used a build list function, just the same. So here, yield. Well.
Yeah, as long as you turn the yield into an add, I think you should be fine.
Yeah, probably. Thank you. For some reason, still. Because I've specified the return type of this function. So we can have build lists. We need to. Okay, we need a return type to make compiler not to guess the return types and so on. And here, what we have is window. Then we need to specify what collection we want to be processed here. So this is practically the same code. Not sure which one looks better. For me, As usual, when I solve such puzzles, I'm not a competition programmer by any means, but I just use whatever I'm used to, and if it produces the right answer in some reasonable time, I'm pretty happy with that.
Yeah, of course.
And here the input string is not that long, so it's probably doesn't matter what to use. But what I wanted to show that with the repeat, here I can easily add all blocks occupied by the same file into the resulting sequence or list, and then again also add some free space with the same repeat. Maybe this if is not needed, but here I was just lazy to count the number of characters, digits in the input string to be sure whether the RAS space is at the end. I guess here in the at least in the sample input there is no free space at the end. So we actually need this if. Again, we could mitigate it, work around in a different way, just by adding an empty character after, or zero after the input. So, for example, I don't know if here we would put it like this. We will ensure that there is at least there is another character at the end. And avoid this if and partial windows again. So this windowed function, it splits the input string into pairs essentially, because we have size of 2 and step 2. Pairs of digit which represent a file and space after it. And here, this is how I parse the input. There is actually a function zip with next in a standard library that I almost thought that what I need, but it produces all sequential pairs with the step 1 from the initial string, from the input string. So I may have used it, but then I needed to skip every second pair. Not sure what. Again, there are many possible solutions, I guess, here, but my worked from the first attempt, and that's it. Actually, this is the first time I'm looking at it again after I wrote it and figured out that everything works.
It's a little bit of code archaeology.
Yeah, even though I wrote it like 10 maybe hours ago today. Yeah, that's this is exactly that feeling when you're going through some legacy code base, you're figuring out some shitty code and you want to know who is the author, you do git blame and you realize it was you.
Yeah.
Here I don't need git blame. I know it was me. We are still not solving puzzle yet. Another very useful function, and you've already mentioned it. It is debug print. It will not appear anywhere in my puzzle because I removed everything before showing it, before pushing it to GitHub. But I used it quite a lot because it is a visualization of some kind in itself. So after when I started to solve the puzzle, I wanted first to quickly solve the first part to get to know what should I await in part 2. So I have started with a with the simplest possible visualization in its debug print. So it doesn't need any explanation. And here we finally get to the solution. And the solution for the first part appears to be, I would say, straightforward. You just do what is written in the puzzle statement. So we need to move files from the end of the disk closer to the start of the disk, where there is a free space. So we need, basically I have 2 pointers here, first on the first free block and the second one to the last block occupied by some file. This is the start pointers, and then while my file pointer is greater than free pointers, so they haven't crossed in somewhere in the middle yet, I check if the current block isn't free block, and then I just swap them. Oh, well, swapping with the free block, I assign the free marker to the block previously occupied by a file. Then I again move the free pointer to the next free space, and this is obviously not the most performant way to do that, because here essentially on every step index of function needs to go through the whole array or list, whatever is the underlying data structure, to figure out the first free space. Because, well, at least the very easy optimization here would be to start with the current known free pointer. So we are absolutely sure that before the block with the number 3, there were no free slots available. And yeah, and then I just move to the next block in the direction from the end of the disk to the start, so in the reverse direction. And here delay, you don't really need a delay here to solve the puzzle, but we'll need it later in our visualization. And well, that's it. And I probably can show what I came up with.
Oh, we finally get to see some composed multi-platform. Very nice.
Yep. Here it is, and yeah, these circles represent blocks on disk. Great ones are empty space, and the different shades of blue are files with different IDs. And if we run part 1, it starts defragmenting it and moving blocks from the end closer to the start. And at the same time, it also updates the checksum live. And 1928, as we've seen in the puzzle description, is the correct answer.
Very nice. Okay.
So, should I show the?
Can I just ask you briefly? Yeah. Do you want to briefly explain why indices? Because of course the actual list is much longer, right? Can you briefly explain to you why you're not running into issues with indices that are larger than 9? Like in your characters?
Not sure what What the question is?
Because your IDs become like, at least when you use the real input, the IDs become a whole lot larger potentially than just the digits 0 through 9.
Yeah, I see. So my ID is actually an integer. So here ID is an int. So and here when I'm parsing the input, I incrementing it after each pair of file block and the free space block. And the blocks, how I store them, it's the list of integers where this list is the whole disk, all blocks on the disk, where free space is represented by integer min value and non-free space is represented by the file ID. And in the input, these are the length of different files. So the file cannot be longer than 9 blocks in this puzzle, but its ID fits in integer just well, because we have only 20,000 of characters representing the whole input. This means that the highest file ID is 10,000.
Okay, yeah,
does that make sense?
Yeah, of course. That fits great. It's the main reason why I'm asking here is because a couple of people, of course, while we were chatting earlier, said that they maybe got hit ever so slightly by maybe making the operations directly on the strings, for example, or generating some sort of materialized view of this list. And then if you do that on character basis, well, you might get more than one character for one thing if you're staying in the realm of just decimal numbers.
Yeah, probably. So I was, as I said, I kept in mind that I will need to visualize it from the very beginning, so I immediately converted it to represent the whole disk, because that's what I wanted to show.
Very smart. No, that's a pretty good move. We'll take a look at part 2 in just a second, but I do want to compare this briefly to my solution, which I'm just going to bring up. I don't think it's going to be particularly surprising here, but we can still take a look. I decided, well, the first decision that I made was, okay, I can probably just materialize this entire thing, right? Because this is whenever a question comes up, for at least for me, where you have a list of numbers that looks like this, or a list of numbers that looks like this, you need to make a decision, which is, can I instantiate whatever this actually stands for in memory? Or will I immediately have to work with some layer of abstraction, like just keeping track of the chunks somehow, or so on? But for part 1, I can absolutely get away with also just generating a list of integers, which just creates these segments. We can take a quick look here how I'm doing that part. I'm parsing the segments just by going through each character, assigning an ID, which I decided -1 is a free space. That was your integer min value. Otherwise, I just assign an incrementing ID, and I use digit to int for the rest. Nothing particularly wild here. And then from there, I do the same thing that you do, with a probably even less efficient approach in this case, which is just I'll look for the first occurrence of a -1, which is a space, and I'll look for the last occurrence of a thing that was filled. So now I have an empty space and the last block that wants to be moved. If it so happens that the first open space is after that last used space, that means we already have everything sorted in its entirety. We don't really need to make any more changes. Then we can just make the swap in my mutable list, So just at the first open space, we'll move whatever was at the last used space. We'll clear out that last space because we don't want to duplicate things, and we just do that until we finally hit our exit condition. That's pretty much all there is to this approach. Is it fast? Not really. Especially like doing like index of first and index of last. It's not like the speediest way. It would be much better to just kind of continuously increment pointers or like increment indices and see where they land, just like you mentioned as well. Wasn't really necessary here. And then I calculate the checksum, which I originally started out by just putting into an integer, which was a terrible idea. But what was a great idea was me being overly cautious and doing a bunch of print debugging. Like in here, I just had a like print line checksum all the time, which meant that in the case of printing with I guess this now has a long, but if I turn this into an int, and I hope that, well, I can't compare it against my check, so give me 2 seconds here. This is a certified Sebi advent technique, because if you print this now, you will notice that the sign tends to flicker between like pluses and minuses, and you're like, okay, I have an overflow. So sometimes just adding a bunch of random print statements in different directions can help you a little bit. It does ruin your runtime performance though, so make sure you delete those.
Correct me if I'm wrong, but I think there is the first day this year where we actually needed to have longs instead of integers.
You are correct. That's absolutely right. What I also like, by the way, hearing here is that apparently there's a JVM agent that allows you to throw on overflow. Jonathan, if you have more information about this, or like a term that I could Google to find this out, I would be curious to hear more about this, because this does seem like it would become very helpful very quickly in Advent of Code. It is the behavior, like a safe add and safe subtract are kind of the things that you want, at least while you're prototyping these. But yeah, apart from this, I think the solutions are fundamentally, I think they're quite similar, right?
Almost the same.
Yeah. So let's see if we end up deviating in part 2 of day 9. The reading hat goes back on, and we'll see. I'll be quite honest with you, given the theme of this, defragmentation, I had a little bit of a hunch of what might happen in part 2, because you typically you will probably want to move things together that belong together. Okay.
Yeah.
So, part 2. Upon completion, 2 things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea. The eager amphipods already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. This time, attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID order, starting with the file with the highest file ID number. If there's no span of free space to the left of a file that is large enough to fit the file does not move. The first example from above now proceeds differently. We start with the file 99, and we move it to the first free space, which happens to be this space of 3 elements. Then we have a file with 4 8s, which we can't fit in this 1, we can't fit in this 3, and we couldn't fit, and at the time, we couldn't fit in this block of 7s. So this one just stays. Next up, we have the 7s block, which we can actually move into this free block of 3 elements. So the 7s go over here in the 3s. Then we take a look at the 6s. We'll see if we can move them. We can't. We'll take a look at the 5s, see if we can move them. We can't. Take a look at the 4s, see that there is indeed a space that is large enough to hold these, which means the 4s move over. And then we take a look at the 3s, and then the 2, which is kind of like still remaining here. We find a space that happens to be 1 element wide, so we also move that one. The process of updating the file system checksum is the same. Now this example's checksum would be 2858. Start over, now compacting the Amphipod's hard drive using this new method instead. What is the resulting file system checksum? Victor, let me ask you this first. Do you want to give us like a brief historic session, like a brief historic reason for like defragging and why that was necessary, just as a little like interlude?
Yeah. I tried to remember where, if I have hard disk drives anywhere. I remember that, I still have a desktop computer in the office, which is like, I don't know, 10 years old, running Linux quite well. What could I ask for? But that's probably the last one I have with hard disk drives. And nowadays we have solid-state drives everywhere, which allow almost random access to all available memory, and it doesn't matter where the files are physically located on the drive. And because, well, the solid-state drive is like small chip where you can really know where the files are located. And with hard disk drive, these were quite a big magnetic disks. Really, that's why it's called disk, because solid-state drives are chips and not disks anymore, and we still refer them as disks. Yeah, and on these magnetic disks, you read information sequentially. You cannot access it randomly. Because you need to position the needle which reads, like on the vinyl discs, the basic principle is the same. And you can only read a sequence of blocks, I guess, and then you need to reposition the reading head to some other part of the disk to read another set of blocks. So if the single file is split into different regions and different parts of the disk physically, then you have hard times reading it, and your I/O performance is quite low. That's why we needed to defragment the disks back then. I don't remember when I did it last time. Many years ago.
Interestingly enough, I believe starting with Windows 10, the defrag operations happen in the background on an automated schedule. I think it hasn't been user-facing since probably, I want to say Windows XP, or maybe even before that, maybe like Windows ME, something like that. But yeah, it's also the fun part where, you can like literally hear if a disk is like very fragmented, because it'll just have to move the head a lot more, so you hear a lot more clicky noises. So yeah, it would make sense that if you wanted to compact out some space, you would want to move things that belong together in a space that is physically close, because you will most likely read them in a row. So I'm gonna throw us back over to your screen here, Victor, and you can tell us a little bit more about how you approached this.
First of all, I forgot to show the checksum function, which luckily was as useful in the first part as it was in the second part, so I haven't changed it. And yeah, I have it as a separate function because again I need it for visualization. So, and my solution for the second part is pretty messy, I'd say.
Okay,
And
let's see if we can make sense of it.
yeah. Again, maybe for performance reasons, probably having some sort of sparse array where you move files as blocks, especially in the second part, would be much better, much more performant. But as I was targeting the visualization, I anyway needed to move all individual blocks and reassign them. So I thought it doesn't matter. Again, I think that for the purposes of visualization, I still have a delay here, and it's all the performance I possibly could have get here, because sometimes you just need things to move slowly, just to see them, just to make some sense of them. So here, what I had here again, I have a pointer for the last file. We start with it. We move until we reach. We go past the first available free space. Here we don't have a pointer for the free file, because as we've seen in the sample input, we can go beyond the first available or the last available free block. So it's here the thing differs between the first and the second part. So just another sanity check. I'm not sure I need it, actually. It should have stopped earlier here, but I just put it in here, even wrote a comment. I guess it's the only comment in this file. I don't know what I was thinking about, but it is here. Maybe this is an example of some poorly commented code, because I think the command here, it explains quite an obvious thing, and what happens here, God knows. we'll figure it out right now together.
Yeah, just as a quick note here for people, just because I saw the question about what is free, that just happens to be integer.min value. It just has a nice little name here to represent a free space.
Yeah.
Okay.
Just to make it a little bit more readable without adding any comments here. Yeah. So if the current block we are processing isn't a free block, it is a file, with this index of call, we find the first block occupied by this file, and since they are continuous, we quickly count the file size, and yeah, +1 here, off by 1 error, my favorite error. Of course, in the very first iteration, I forgot to add it, and then I got the file size of 0 for some blocks, and then had an infinite loop somewhere here. We'll get back to it. So then I find the first available free block, of which can fit the file of the given size, and here I make sure that it really exists. And here a tricky part, we should only move files closer to the start of the disk. We shouldn't move them back. So this condition here is very important to solve the puzzle correctly. Here again, it's just reassigning blocks on the disk. I really like this new Kotlin operator to have non-inclusive range. Before we needed to use until function. Now I guess starting with Kotlin 1.9 probably. I don't remember when, but now there is an operator for that. And yeah, here again, a possible place where one can get off by one error, but that's basically it. We go backwards a little optimization. We do not need to scan everything again. We go back for file size blocks. And the only thing I haven't shown yet is this find free block function. And here again, for some reason, I like using this window function today. And here in very inefficient way, because what it does here, it tries blocks of file size length, and it does it from every possible index. So don't repeat at home. It is bad. It is not performant code. Well, it is not bad because it is correct, actually. So what we do here is I get all the possible windows of like block ranges, starting from the very beginning of the disk, which I may already know is not empty. It doesn't matter. Then I'm trying to find the first, which has all its blocks inside free. And that means it will fit this file. Voila. Here we go.
Very nice.
Yeah. That's it. So we can quickly so we have this disk defragmented. We can switch. Oops, something wrong with my layout here. So here the puzzle input, my input, I guess there are many available for different players, for different participants. You cannot tell exactly what is here. There are a lot of files and also a lot of free space. We see these gray squares, gray circles everywhere. We may I'll show it later, but we can quickly make them red. So you see there is a lot of free space in here, and we can just run it. And starting to notice how this free space appears at the end of the disk, and all files are moving closer to the start of the disk. I'll make it back light gray because I love this color scheme, and I can watch it like fire in a fireplace. It's so delightful.
It's gorgeous. It really is just very, very satisfying. This is very nice.
Yeah, so we have a lot of free space at the end of the disk. The start of the disk is starting to fill. There are some free short blocks block ranges at the beginning still, but we are getting closer to fill everything.
And it really it does go to show how much space there is that can be freed up just by opening up those or by filling those little gaps that weren't quite as noticeable before. I mean, that's almost like it's almost half of the free space that was reclaimed here.
Yep, exactly. Something like that. Haven't verified it. There are still some empty blocks in the first half of the disk, which are not possible to fill in. And here we see that actually the proposed algorithm to do the fragmentation is not that good in the real life, because we see a lot of free space here and some files that could have been moved there, but they haven't, because we only process files in order, in the reverse order. But yeah, if it would be enough to find the chief scientist this year, that's okay.
Well, I do have a small question now, which is, why is the checksum still updating? Okay.
It just up because actually, and we've seen it in a sample, we can go past this midpoint where it looks like the first half of the disk is already full, but it isn't. There are still some smaller spaces there and smaller files somewhere there. They're still getting moved closer to the start of the disk, similar to the file with ID 2 in the sample.
Okay, yeah, that makes a lot of sense. I'm sorry, I have to say, I'm just a tiny bit puzzled, because I'm looking at my own solution now, and I'm trying to figure out why it worked. So maybe we can take a brief look here at my solution all together, and we can figure out why the heck, what kind of wonderful invariant I was on that helped me do this. Because, okay, we'll start briefly just at the top here once again. So we have a list of segments, and here's my general algorithm. My general algorithm for part 2 is we initialize some sort of block storage. Which that's just, it just gives me a bunch of functions, and it just manages that list of segments as a mutable thing. And here's what I do. I just attempt to move a block further towards the front, and as long as I can find any block that can be moved towards the front, I perform that, and I continue doing that until I can no longer find any blocks to move. And then I calculate the checksum. Now, in my opinion, the longer I think about it, I feel like I should be doing some illegal moves here. But really, like, whenever I attempt a move, all I do is I go through the storage that I have, and I go through it from the back. Like, I go through it reversed. If that segment that I'm looking at happens to be empty, then of course we skip it, because we want to find the first actual data block. So now for that given data block, what I want to do is I want to find the first gap in my contiguous space of memory that happens to have this length, and that also happens to be located before that specific item. And then I just move that segment into that gap. The implementation of these are honestly not that interesting. I think what's more interesting right now, we can look at those, is trying to figure out why I'm allowed to do this and why I got the correct solution, because I'm not so sure anymore. I would assume it is because for every element, I only look at the gaps that happen to be before it. The blocks are ordered spatially. That's why it works.
Yeah. Yeah, I think so. First, in my first attempt, I haven't checked for this. That's why I highlighted this check, this condition in the while loop in my solution. And yeah, indeed, it didn't work. Well, the sample was incorrectly solved. But here, and I wonder if this attempt move. Have you debugged it? This attempt move function called more than once? Oh, well, okay. It is. It should have been called at least twice, but I guess it may have just called once. Did everything? Oh yeah.
No, I'm doing that quite a lot.
Yeah.
Because I'll be quite honest with you, I did the thing which everybody loves doing at Advent of Code, which is not read the description entirely. And as I just did the dramatic reading, I was like,
yeah.
Oh wait, what?
Well, okay. Then because we all got different inputs, maybe it happens so that your input puzzle is a bit different, and it just forgave you for this small
maybe
deviation. I don't know.
Maybe. I mean, Herbert mentions that the blocks are ordered spatially, which I'm not sure if that means that as an invariant, attempt to move should only be called once for any file. Okay. Yeah, this is an interesting puzzler. Here's here's what we're gonna do. I'm gonna put a link up to my behind the scenes, and if you would like to, you could open an issue with a brief explanation of what the heck it is I'm doing wrong, and or let me say why it works, what invariant is in here. And I'd be curious to hear it. Because again, like what I implemented here, or at least what I attempted to implement, was moving all of the files as far to the left as possible, as long as there was still a space, because that's how I understood defragmentation to work, like intuitively. But I guess that might not be the case here. Yeah, the funniest errors come from reading the docs. I don't read them too. What's way funnier is when you don't read the docs, you implement a different algorithm and it still works somehow. So that's curious.
Sometimes you just get lucky.
Yeah, maybe. But yeah, so this is a part 3 for all of you who haven't had enough puzzling today. I would genuinely be interested in an explanation. I will just briefly go into this though in my attempt move. Again, there's nothing particularly special in here, but I have a first gap of minimum size, which just looks for in my storage an element or a segment that happens to be empty. So ID is -1, and where the size is longer. And if that element happens to be above or at that before index that I pass in, then I just return null. And if I can't find a gap of that length, I'll also return null. And yes, so actually moving the segment is just a bunch of array stuff. You first of all grab yourself the gap that you'd like to move into, then you grab the segment that you want to move. You calculate how long of a remaining gap you have, because if you don't do that, then you're just kind of eating up some memory. You create a new segment for that. Then you zero out or you -1 out the segment from which you moved your file away. You take that gap index that you originally got and you write that file to that specific location. And if you happen to have remaining space, then you add that back at the given index. Martin says that the code works perfectly fine with his input too. Interesting. So that is curious to me. But anyway, that's what a wonderful part 3. So, Victor,
Yeah.
there is one thing that I noticed though for now, and I'm gonna switch back to your screen here real quick, which is that
Yeah.
so far those visualizations have all been composed for desktop.
That's true.
But it's called
But-
Compose Multiplatform. So what's up?
And it's called Compose Multiplatform for a reason. So here, for example, I have Android simulator with the same puzzle. You see, even the answers are the same.
Oh yeah.
Here, I have an iPhone simulator.
I love the
can
responsive
switch,
design.
and I can switch and run it on iPhone as well without any code changes.
That's pretty cool.
It runs. Yeah, it is hard to see here, but it runs because, well, that's the zooming part that was out of scope for today. I'd say I could have tried to do something, but no, I didn't have enough time. But you see the spinner is spinning, the checksum is updating because we are moving files from the back to the start, and that obviously reduces the index component of those multiplications we sum up for the checksum. But what I also wanted to show you is this, and this is Compose Multiplatform for web, and it also runs just fine in a browser. That's why I put the whole input into a string constant right into the file, because you can load files in the web. The whole web is about loading some content from the internet, but it is a bit more complicated than on the desktop, as you need to be asynchronous everywhere. And again, that's not what I wanted to spend my time on today.
Makes sense. But hey, you took a single visualization, and all of a sudden we have them running on desktop, Android, iOS, and the web, which is like really cool. That's a real delight, and it's also, I think, a particularly great time to shout out Compose for web running on WebAssembly, because if we take a look, currently Safari 18.2 is, I believe, in beta, but yeah, look at this. It's released on December 10th, which is in the future at the time of recording. But if we take a look here and we command F for WASM, we can see that new features are added support for WASM garbage collection, which is really cool, because that means that going forwards on a Mac OS that's been recently updated, or on iOS 18.2, you can also run Compose for web, compiled to WebAssembly, and you can run it on an iPhone as well, which means that essentially at this point, any modern browser and any modern mobile device is able to run Compose multi-platform for web, which is, I mean, that's awesome, right? Like, it's such a great way for us. It's a great way to bring advent of code visualizations up there. But in general, if you have an app experience that you build with Compose, like bringing those to the web as well, that's pretty cool.
Yeah, and I have a proof. Could you please quickly switch back to my screen?
Of course, we're back to your screen.
Here I have a Safari technology preview, which is what Safari 18.2 will be tomorrow. And here the same app running here. in Safari.
Amazing.
It is on macOS, but we're pretty sure it will work just the same on iOS as well.
Yeah. So now that means if you build a multi-platform app with Compose multi-platform, you can just bring that app experience to mobile devices without your users having to install anything. They can just load it up. And as long as they have iOS 18.2, which luckily the iOS world especially is pretty good at keeping devices on pretty high operating system numbers. Those folks will all be able to use your app straight out of the box as well. Now that's what I call a real nice little Advent gift here.
It is.
Awesome.
It is.
So thank you so much for that. I do also want to redeem one of our previous guests because we had Olaf on just a couple of days ago, and his stream was even titled Advent of Code 2024 in Kotlin with the Visualizer, which I think is a title that he well deserves for everything he's done in previous years. But he got a task that, we did some graph viz and we saw that on screen, but that wasn't exactly like what you would probably expect. So in honor of that, I have a visualization from Olaf, which he sent in, which is in his classical fashion using his custom drawing framework, and we can see here again that it does in fact fill or clear up a whole bunch of memory quite nicely with a slightly different color scheme. I'll be quite honest with you, Victor. I think I prefer the shades of blue. Oh.
Thank you. But I really like the status progress here at the bottom, which not only moves the files visualizing that, but also logs all these moves down there.
Yeah, I think this is and I mean also very very tasteful like window frame. That's also once again very reminiscent of Windows 95. Like very very cute design. So yeah, and I'm looking at this, and at least at this zoom level, I'm now very curious to see if Olaf's solution doesn't leave a single empty space. We'll see. Because so far it's looking pretty contiguous.
Mm-hmm.
And maybe that is also the explanation of why my algorithm may have worked. Because if you can fill every space, I guess you can't. Never mind.
Okay.
Maybe
it's just the zoom in. You can really tell whether the gaps there are big enough to fill the files that are still remaining at the end of this space. No, but
I think those are But anyways, yes. So thank you so much, Olaf, for sending that in. We do of course appreciate it as always, and thank you so very much, Victor, for coming on today. That was really great.
Welcome.
So
I enjoyed it.
I'm so glad to hear it. That is just excellent. It's always great when you get to share the joy of puzzling with a couple of other folks. And to everybody at home who decided to tune in today, of course, we would love it if you were to come back for the last 3 streams. So head on over to the YouTube streams tab and make sure you hit notify me for these 3 streams that are upcoming so that you don't miss those puzzles. Once again, we still have a couple of wonderful guests coming up. I am certain you don't want to miss them. Apart from that, Victor, thank you so much, and thank you to everybody who decided to tune in. And we will see all of you tomorrow, because there is only 10 hours and 40 minutes left. I get a question here in the chat, which is why stop the stream at day 12? The answer is a very simple one. Because I will also be going on Christmas holiday at some point. And this seems like a pretty reasonable place to have it.
You deserve it.
Yes. You know what? I do. I think so too. So, yes. But until then, we will still have cool puzzles and cool conversations and maybe some cool visualizations. Who knows? So, make sure you check back tomorrow. We would love to have you. And of course, I'm not sure if we're still doing this, hit the subscribe button if it's not yet clicked for you down below this stream, I suppose. So, thank you everyone, and see you tomorrow. Goodbye.
Bye.